My name is Kenneth Parker. I'm the chair of the brand new Department of Catholic Studies here at Duquesne. And Catholic Studies and our co-sponsor, Math and Computer Sciences and the Gumberg Library are very excited to welcome you to this first presentation of the semester for us. Special presentation, gigabytes, terabytes, and petabytes. Oh my! Our speaker is as engaging as his title, Danny Michaels. I've known Danny since he was a graduate student, and I was a young professor at St. Louis University. When he was working on his PhD in Franciscan studies, did a phenomenal and unique dissertation that involved the building of a virtual model of the Basilica of St. Francis of Assisi on a gaming platform. So this gives you some idea. His work in the field of technology and data visualization goes back to the late 90s. So I'm going to, he's now the Chief Technology Officer at the National Institute for Newman Studies, which is digitizing the manuscript material of St. John Henry Newman. I will turn things over to Dr. Michaels, to Danny, and let him get on with his presentation. Thank you, Danny.
Thank you, Ken. I'd like to, first of all, start by thanking the Department of Catholic Studies and Gumberg Library and the Department of Math and Computer Science for sponsoring this event. Your insight and guidance over the years and support from Duquesne University in general has really helped us get to where we are today. I'd also like to thank the students at Duquesne University, some of whom I see are actually on the screen right now, who continue to help with our digital collections. I'm really proud that we've been on this journey with Duquesne University and even more proud of our affiliation. I'd also like to thank my colleagues on the board at NINS for your unwavering support. Now, let me share my screen. The title, Gigabytes, Terabytes, and Petabytes, oh my, reflects that deer in the headlights feeling we had several years ago when it hit home that we needed a larger, or at least more efficient, infrastructure, and the journey to big data was going to mean dealing with lions, tigers, and bears. Oh my. The following is our path to, I guess, digital Oz, and what we found when we got there. We'll start with some historical context, a history of the project, which, as you'll see, is the story of our encounter with big data and digital archives. And in many ways, it mirrors the story of many other libraries and institutions. We'll do an overview of the platform and some of the key decisions we made that helped us deal with gigabytes, terabytes, and petabytes. We'll also we'll talk about the promise of big data in digital collections, specifically the 4 pillars of the things that we do in digital collections and what digital archivists are about: creating, annotating, discovering, and imagining. Finally, some future possibilities. So let's dive right in. The historical context, this is important because, as you'll see, it impacts the decision we make currently about what we do with our archives. In 2005, we began digitization of about 2 million pages of published works. And by published works, I mean the things that Newman wrote and published over the years, Arians of the 4th century, and so forth. This was a collaboration with the University of Toronto, St. Mary's College in Boston, the Pittsburgh Oratory, and a company called Crivella West, which helped us with the first system. In 2007, we opened the Gigabytes Center for Newman Studies, where we're currently located. In 2010, 11 years ago, we formed our affiliation with Duquesne University and created the Ryan Endowed Chair in Newman Studies, which Ken currently holds. In 2013, we began the digitization of Newman's handwritten works, which are about 250,000 scans of letters that he wrote that were also written to him. What's interesting about this collection of letters from the Birmingham Oratory in the UK is that about 65 to 75% of them have never been seen. So you can imagine the new things we're finding every day and sharing back and forth between our colleagues at NINS. It's quite exciting. In 2018, in light of what we learned from our colleagues at Gutenberg Library and other institutions, our affiliation with IIIF framework, which I'll explain shortly, we decided to go a slightly different direction with our digital collections and launched a new platform that you're going to see today that sort of signifies the direction we want to go moving forward. In 2019, John Henry Newman was canonized, and we published the first version of this platform. In 2020, Catholic Studies program was created, and that's where we are today. Now, if you look at this chart, this timeline, you can see that pretty much up until about 2016, we were all about preserving and protecting archives. And this was a very worthy endeavor, as it was for any library. But what we discovered that a lot of the mechanisms that were in place for institutions, not just NINS, but all institutions, were making a transition to sharing in a different way rather than protecting. And so from then on, it became about preserving and projecting rather than preserving and protecting, even though protecting is still a component of what we do. So everything we do moving forward has to do with this notion of projecting. That's me and our lead archivist, Lawrence Gregory. The boxes behind him are the 250,000 papers that I mentioned. You can see there's a very suspect character in the background, kind of grinning at us. Thank you, Ken. But the breadth and depth of our collections, about a 1/4 petabyte of data, is indicative of many organizations. We have 4,500 books, articles, and journals totaling about 2 million pages. That's about 200 terabytes of data. A terabyte is 1,000 gigabytes. So we're talking about a lot of data. We have 19th century manuscripts, as I mentioned, about 240 boxes. That's 250,000 pages. We have books, articles, journals, unpublished letters, notes, poems, musical scores, photographs, and we're considering adding 3D architecture and objects in the future. So that created a little bit of a problem because we realized that we couldn't just take something off the shelf because we had so many different types of assets, of media assets. So we decided to build an infrastructure that could accommodate them all while being flexible enough to connect with other things. So before we dive into the nuts and bolts, I just want to give you a quick overview of these interfaces, kind of what they look like. So you know when I mention the admin interface, this is what I'm talking about, and the user website. So if I were to look at these, the admin interface is basically an application where we have a dashboard that shows us the collections themselves, where we can view what items or add items to a specific collection or edit the collection. And we can create as many collections and sub-collections as we want. It's really infinite. We only have these so far because those are the ones that have meaning for us up to this point. The items section includes documents. This is sort of where the rubber meets the road, where we actually add data. So if I were to click on one of these documents, it should open up a document editor, and you can see all of the metadata on the right-hand side, the document notes for our curators to talk about where it came from. Canvas metadata has to do with the actual canvas, this information. We can do all sorts of things with this. I'll go into a little detail later. The Lightbox is a place where we can create documents from our archives, from our existing archives. So if I were to go to, this is box 80 or 79, box 80, album 1, our archivist created this box so he could use it to drag images into documents. Again, I'll have an example of that later. An author manager to manage all of our authors with links to their books. Coverage manager, this is where we define where things were written or written to. a user manager. This is just who's in our system, who uses our system, our admins, our users, and an asset manager that links to our cloud-based infrastructure for holding our images. So that's like a 1,000-foot view of our admin portal. The main portal mirrors all that same content, except obviously we can go in and we can view the documents. We can sort them in different ways. If we click on a document, it opens up a pretty advanced viewer it's an open source project called Mirador from Stanford and some other collaborators, where we can do deep zoom and look on different objects. We've got our metadata down below. It stores other data such as transcriptions. Here's a repeat of the metadata. You can bookmark, you can change the way it's organized, perform searches, all that sort of stuff. We also have the other collections that are on here, which are similar looking. Some data visualizations where we're able to organize our data in certain ways. Again, I'll go into some examples of this later. And then just some featured collections. So that's just like a 1,000-foot overview of the actual interface. Now, when we met, I'm not sure how many people are with us that met with us 2 years ago when this project started. When we started, we were merely trying to figure this out. So we were trying to say, how can we get this 1/4 of a petabyte of data, not including the metadata, how can we get this on image servers in a way that's meaningful and we can deliver that amount of data in that sleek looking platform that I just showed you fast enough? And we were sort of stumped, and we went over some options of how we could organize it. And what we ended up doing, and this is pretty innovative even in the IIIF world, is we store everything inside this orange line here that I'm going around is all in the cloud. I have this little AWS here because it's Amazon Web Services. We store their individual servers like this. This is a server. This is a little mini microserver with a function. This is an image storage archive. This is a sync function. There's all sorts of different things going on here. And believe it or not, this is sort of the simplistic view of our architectural diagram. But my main point is it functions in the cloud. And we found a way to sync our images with our image server through this, what's called Elastic File Server, that we could deliver massive amounts of image. And that allowed us to jump in and do other things, more advanced database structure, advanced search, optical character recognition, and other advanced things that we were able to accomplish because of this cloud infrastructure. It's relatively affordable and it's scalable. So at any given time, we can go up or down depending on what sort of things we need. So that's high-level overview. Now, in terms of that architecture, 4 things emerged as important for big data, for gigabytes, terabytes, and petabytes. And the first one was an affordable, scalable cloud infrastructure with creative use of auto-scaling servers. Lambdas, which are like on-demand pop-up microservers, elastic file solutions, I showed that to you briefly, third-party high-memory databases, search, and more. With this allowed minimal heavy lifting for our curators and our developers. Our cloud infrastructure is modular, so we could easily spin up or down any portion of the system depending on our needs. For example, if we assimilated a large institution with a large institution like Duquesne, and we wanted to access their document asset management system, or had to play with their content management system, which is much bigger than ours, or even their own IIIF servers, we can simply remove those elements and modify our programming interfaces and other scripts that connect those pieces to our users. Thus, our cloud system is more like Legos than pre-assembled toys. Even our template system, that look and feel that I showed you earlier, is modular. It does not lock us into any one particular way of storing or retrieving the data. The second major thing was we decided to make this a NoSQL solution, which means we can store unlimited sets of data of any type. The data can be changed on the fly, and it's document-based and horizontal. That means there aren't tables upon tables stacked up. NoSQL is also ideal for agile environments which need frequent feedback and fast iterations. And it plays well in cloud-based systems, which worked well for what we were trying to do. With a non-relational database like this, we can build what makes sense for our users instead of only conforming to the limitations of machine-readable files or encoding standards. And we can change with our users and technology as they grow. Now, before you glaze over too much, let me put this a different way. NoSQL solutions like ours, which are considered horizontal, store information like you would a recipe in a book. When you want to know how to make a cake, you go to that recipe and all the information about how to make the cake, the ingredients, the preparation, the mixing, the baking, are all on that one page. Similarly, if you want information about one of the resources in our digital collections, you'll find a recipe for that entire resource in one page. A SQL database is more like shopping for the ingredients for the recipe in a grocery store. In order to get all the ingredients into your cart, you have to go to many different aisles to get each ingredient. When you're done shopping, your grocery cart will be full and all the ingredients you had to run around to collect. Wouldn't it be nice if there was a store that was organized by recipe, so you could go to one place in the store and grab everything you need from that one spot? Granted, you'll find ingredients like eggs in 50 different places, so there's a bit of overhead when stocking the shelves. But from a consumer standpoint, it would be much easier and faster to find what you're looking for. Our NoSQL database is similar. You'll find eggs all over the place, and you'll get them in an instant too. In light of our design goals, we required a comprehensive API, or application programming interface, that allows us to safely share data across our applications and with external institutions. In very broad terms, you ask the server for a certain data or ask it to save some data, and the server responds to those requests. In programming terms, there's an endpoint or a URL that the server is waiting to get a request. We connect to that endpoint and send in some data about us, and the server responds with the correct response. In other words, it's a mediator between the user and the client and the resources or web services they want to get. In fact, you're using an API right now. The browser is acting as an uncontrolled REST client, fetching what you asked for from Zoom during our presentation. So Zoom itself is providing the API, and your browser is sending requests back and forth based on what you want. Finally, speaking of APIs, one of the most critical for our purposes is the International Image Interoperability Framework. And it's sort of unfair to call it image interoperability because it should be media interoperability because they accept 3D objects and media and video and so forth. IIIF provides a common language for retrieving and disseminating images, annotations, and other media. Encoding images in document viewers with this common language allows institutions to load massive data, images, et cetera, into browsers. Most archive systems build plugins to accommodate IIIF, like ContentDM and other platforms. They allow IIIF media to be viewed in their system along with some functionality to render it, but our system, on the other hand, places IIIF at its core. So any action we do generates IIIF code automatically, and any other functionality is built off of that base. We build functions and features that go well beyond IIIF, but these are stored in a structure that can be accessible to IIIF resources. IIIF provides an API that makes up our framework, and we can only talk about two of them. They actually have five. One is an image API, which defines how we load images onto a server. Another one is a presentation API, which defines how you can look at that image in your collections. A search API, which, as the name says, it's all about search. Authentication has to do with what you can see or not see. And discovery is what you can find either externally or internally. We're only going to talk about the first two. Now, just in general, IIIF makes extensive use of tiled images. Those who have seen me present before have seen this image many times. The strategy is similar to Google Maps or Google Earth, whereby pieces and parts of images are sent to the viewport as needed instead of downloading entire images all at once. A tiled image contains multiple layers, such as you see here, and each is divided into slices, sort of like a wedding cake. Like you can see all those slices there. The bottom layer is full resolution. The layer above it is half of that resolution, and so on. Each successive layer gets smaller and smaller. The red square in each of these images represents what you might view in your web browser. The image is too large to see all at once if you're completely zoomed in, so the image server only sends the bytes that you need to see. So we're talking kilobytes instead of megabytes. One of our typical images, a full-size image, is about 100 to 150 megabytes large. If you can imagine that you had to load that much data every time you loaded an image, it would be overwhelming. This is probably 30 to 50 kilobytes of data because we're only grabbing slices that we want and they're all predefined. Now, when you upload an image to an image server, it automatically creates this code. Now, you remember I talked about the recipe? This is the recipe for a IIIF image. It's showing us what the coordinates are, what the dimensions of the actual image. And if you're on the left side of the screen, this is the actual image that's on the screen. So if I were to click this image, I'm viewing this image off of the image server. And if you look at this URL, remember I told you that an API sends requests from the browser to the server and it fulfills those requests? What I did here was I asked it to give me the full image, but only give me dimensionally 1,000 pixels of it, because the full image is like 8,000 pixels. So if I were to change this URL to say 500 pixels, it automatically changes it. You saw how quick that happened. That was all through the magic of IIIF. I could even just say, you know, I only want 10 pixels. And you get that little teeny tiny pixel, you'll get a couple little things off the top of the pile. So let's go back to 1,000, or at least 100. Actually, let's go up to maybe 500. You can also do things like say, I only want certain coordinates from this thing. So instead of the full image, let's back that up, and let's grab those coordinates from that image. Or maybe I want to rotate this image. So I'm going to rotate it 45 degrees. Or maybe I want it to be in black and white. So I'm going to say gray. And there it is gray. Or maybe I don't want a JPEG, maybe I want a PNG. And it creates a PNG. Now, all these things are happening, obviously, very quickly. I didn't pre-record this. I'm showing you this in real time. So if you have a website, you know, like if we're on the front-end website and I go to a document, I am calling up that image resource for that document to view this document. In fact, we might as well look at the actual document that I was, actually we're already here. Yeah, it's that same image. We can tell our browser to look at those images in whatever way we want and flip them and rotate them and do whatever we need. We also need to show them in the browser. Don't get too hung up on this. This is the recipe for the images on the front end of the website. In fact, if we go to this particular one, I can go here and click on the manifest, and it shows you the IIIF recipe for that document. If I take this recipe, this cookbook recipe, and send it to any other institution that has things that run IIIF, they will be able to view our document just like we're able to view it here, including all of the metadata. So our 1/4 of a petabyte of data, when shared with other libraries like Duquesne or whomever, becomes massive amounts of data, because now we can pull in data from other libraries who may have a collection that's the same size as ours. There are several things that we try to do as digital archivists. I've put them in 4 categories. And for us, as I mentioned in the beginning, this is more than preservation. It's about pushing research beyond imagination, or at least to imagination. The first objective when you design a platform like this is you have to be able to create objects. You have to get things in there. And this was, again, the deer in the headlight moment for us. How do we get this much data into a system and make it intelligible? So the raw act of managing assets, importing, editing, managing, and deleting media, we believe this should be free of software code, and archivists should be able to manipulate all points of the digital workflow. In fact, our archivists and our colleagues at NINS work on the same project boards with our developers. So we also have an agile software methodology where we release things in small sprints, which means every 3 months, every 3 weeks and 3 months, instead of months and years for major upgrades. In this first phase of the archive life cycle, our objective is to feed the beast, to get data into the system as quickly and accurately as possible. Now, the second layer of this is you need to annotate, and this requires human interaction and ingenuity. Although we can programmatically organize data, the structure is only as good as the data available. Garbage in equals garbage out. Thus, we focused on building an interface that could automate as much as possible. The third stage is discovery. With larger and larger data sets comes more responsibility to make complex associations between documents. Thus, we spent great effort building filters and full-text search algorithms. Having massive amounts of data isn't much good if users can't find it. And finally, imagine. Digital collections should stimulate our imagination, which means there is an inherent pedagogy and dynamism to the architecture of any digital archiving platform. The ease or dis-ease of data entry, such as we have here, impacts the content choice or the content growth. The ability to annotate or not annotate impacts what we can search. The pedagogy of search or the inability to search guides our research, and the ability or inability to imagine determines whether or not we will grow. Our own St. John Henry Newman spent much time on the imagination, which was tied to his understanding of assent. He was particularly interested in what moves a person to say, quote, "I assent to that. I believe that in my heart." And he makes a distinction between real and notional assent. In its notional assent, says Newman, the mind contemplates its own creations instead of things. In real, it is directed towards things, represented by the impressions they have left on the imagination. In other words, and I'm oversimplifying here, the image or the idea held in the mind pushes one to make it real, to realize it concretely. In real assent, things press on our imagination, not in the sense of fantasy or the unreal, but in the sense of a truth that moves us, or the ones we study, to say, I assent to that. The sense of imagination or of experiencing real things from our perspective or through the eyes of our subjects, insofar as that's possible, cannot happen without encountering the matters themselves. And so imagining takes place when we engage sources directly and profoundly, and not only through the lens of secondary writing. All this is to say that large-scale digital collections should contain tools that allow researchers to make deep connections and do critical thinking while engaging their subjects on their home turf, where things are most real to them. Thus, deep zoom, layers, document comparison, transcriptions, sharing, and more open our imagination while unlocking the imagination of our subjects. And imagining leads to more creating, which leads to annotating and discovery, and thus this is a cycle. So when we as archivists get to this stage, our expectation is that we're going to recreate and further annotate and discover and bring our users into that cycle and have a never-ending process of discovery. Now, what's interesting is one brief example of this imagination was something that I was not expecting from our own archivist. He can actually tell me what we're looking at here these are all writings of Newman. Okay, let's go to a grid view. I'm not going to zoom in on any one particular, but you can see sometimes he's chicken scratching and other times he's pretty uniform. And Lawrence Gregory, our archivist, can actually tell me what mood Newman was in when he was writing a particular article. Because you can compare when we know he was angry, when he says he was angry, he wrote a certain way. And all of a sudden, when you look at something else, when he wasn't so hot, you can see he wrote in another way. And so then when he doesn't explicitly say that he was hot, you can say, those S's and T's look a lot like when he was really angry. And so lo and behold, you have a sort of this angle of Newman, an insight to his imagination, what was pressing on his heart, that you wouldn't get from the published versions of these same texts. This, to me, is what digital archiving is all about. So let's just briefly go over a couple things. The creating for us, we're going to walk through some of how we do this. For us, this was daunting, like I mentioned at the beginning. Fortunately, our agile approach gave us the flexibility to grow into this quickly. Creating in the digital archive sense means uploading the raw data. So we began with the simple act of importing the documents. Now, it starts for us with the asset manager, which mirrors, as I said before, all the images that we have stored on Amazon Cloud. And this is as simple as clicking upload, uploading your files. It determines what the file type is. It converts it. It even turns it into that IIIF. Well, actually, it eventually ends up turning into that IIIF code once it gets to our image server, because anything that we upload to this section automatically syncs with the image server and it's viewable. Once the images are there, the curator can go in and create a lightbox. So they would create a new item where they would select some documents. I'm in batch 2, box 16, album 1, and I might select a couple things and go to create a new document. So I'm creating this sort of placeholder document. I'm not actually going to do it because we have all these other ones already here. Once that's done, I can go into these documents, click edit any one of them, and then I can say import lightbox documents, pick one of those folders. It pulls in that document and all of its items, and I can just drag them to the canvas and add them to this document. And then if I return to edit the manifest, if I were to save this, those 3 pages would have been saved into that document. And when I save it, it produces the recipe that includes those new pages with links to the image archive. So everything is all automated as soon as I save it. And the curator or the archivist doesn't have to worry about creating this code. The first thing you're going to see if you try to learn how to use IIIF is that that they spend lots of time teaching how to create these manifests. Well, that was a little bit overbearing for us. So we decided to build all that into our system. So no matter what you do here, whether it is you're adding an image or a transcription, that all becomes part of the IIIF manifest automatically. We can also do this. Since we have all those image assets, we can take the URLs. Let's say we have a document and we want to import 1,000 pages, like we would have in one of the letters and diaries of John Henry Newman from Oxford University Press. We can just choose all of those URLs to those IIIF assets and import those. And in seconds, we have a 1,000-page document loaded into the screen. And it doesn't get any easier than that as far as creating content for our users. Once we overcame this hurdle, then we could start worrying about annotating canvases and doing more advanced things. Let's see here. So now we're up to annotation. Garbage in equals garbage out. Digital collections aren't very helpful unless you can add meaningful metadata and annotations. We don't have time to discuss the intricacies of the metadata and encoding and how that makes a difference to users. So I'll simply show you our interface and give you one example of how we've automated annotations with optical character recognition. So again, this is our editor. So this metadata is one layer of annotation, but you can also annotate on the individual canvases. For example, let's scroll in here a little bit. If you look closely, you can see that there are optical character recognition. If I mouse over these words, it's showing me the word, and I could technically go in and edit that word. I'm not going to. But this was a scan that we did to automatically recognize all the words so that they could become searchable in the front end of the website. So if I were to go to, let me find one of these things in the front end. Let's go. So that OCR pulled up all those results in the actual book, and the zooming is independent. It still holds all those coordinates. The other thing that you can do is you select the canvases. You can also add transcriptions. Now, these transcriptions were put here automatically by our system when we did the OCR. But you can actually come back and you could highlight, you could format these in whatever way you wanted to match the actual book. And we had some students from Duquesne University a few years ago who actually took a lot of our transcriptions and were in the process of importing them with HTML formatting. For the librarians out there, we can also encode this with text encoding initiative or other initiatives where this is another recipe similar to IIIF that other institutions can use to understand what it is they're doing. We can also import multiple documents. So I showed you, this was all of our old metadata. So we can take all that metadata, and using that API, we can translate it into those recipes that I mentioned, and it just imports hundreds of documents all at once. So if I click upload here, it's going to insert, I believe, box 89, or I can't remember which box we did, box 88. So now all those documents are in there. If I click on one of those documents, it's going to show me the details for that particular document. So then the curator can go back and start working on those documents. He can click here and he opens it up. Now he can enter the label, the description. It just saves a ton of time. So let's go to the next one. So OCR, this highlights our infrastructure. If you want to OCR a document, the first thing we do is we add it to what's called the Amazon Web Services Simple Queue Service. Don't get too intimidated by that. It's sort of like a ticket booth that just sits there in the cloud waiting for us to throw something at it. It's very small, doesn't take up much memory. It's just a service that Amazon offers. It's no separate server. Then we send that to what's called a Lambda, which I mentioned before is a little micro server. It doesn't exist in real space. It's just a little virtual server. Think of this as our little conductor. We're on the train to OCRville, and this little conductor is going to tell us how we're going to get those pages scanned. If there's only one page, it fires up another Lambda, which processes that one page and says, hey, very good, do you have any more? If there's more than one page, it divides them into 3 and sends them to a step function that we wrote to help us understand those 3 pages. It sends them to yet another little microserver that then sends chunks one by one to the Lambda to be processed. The processor says, hey, I got it. Do you have any more? Well, let me check, and so on. And then it sends all of those resultant recipes of coordinates of where those words are to our databases and fires off an email to the end user. Now, the neat thing about this process is this entire infrastructure from here, the entire thing exists in the cloud, but this whole middle section only exists when we need to process images and goes away as soon as we're done. So we can process petabytes of words in relative short order because of this process that we came up with. Pretty neat stuff. So advanced search. Our system has lots of tools for doing search. One of the biggest among them is the ability to search, let's do Catholic education, across all of our documents. So what we're doing here is we are searching every millions and millions of words across all of our documents instead of individual documents. So we can see here, there's 145 results across 23 pages. So if I click on that, it's going to show me those results inside of this document. It automatically performs the search for me. It's crunching all those words now again inside of this document. And once it does it, they're in cache for the rest of your session. The nice thing is you can actually save this then to your profile and view it in your saved searches or your saved documents. This is my favorite documents. I can't remember which one I was just on, but you can save the document once you've done the search. You can also save your search. So if I say I want to do Newman was writing to Ullathorne, and he was doing it in, let's say, 1840s, and the subject was manuscripts, I could save this search, add it to my profile, and I would have access to this in the future, like for researchers who are doing the same thing over and over again. You'll also notice that if we go to a document anywhere on the site here, let me just click on one, we've implemented what we call search engine friendly URLs so that these are all discoverable by Google. And so search is not just about what we do on the website, but what we do abroad. Now finally, Imagine. This is sort of where the rubber meets the road as far as research. And I mentioned some of these things already, and we're gonna conclude with this. One of them is deep zoom, which we did with, let's just click on an image. We saw that already. Again, this is probably 150 megabytes of image that we're deep zooming, just like Google Earth, as quickly as we need to. We have the ability to compare documents. So if I wanted to say, so take something from the music and the music collection, I can add it right to my screen. Or maybe I want to have the correlate of that from the Dream of Gerontius in its published form, and close this one. Now I can compare these two documents side by side, which is pretty amazing. And you can add as many as you want to the screen. The other thing we've done is we've started to implement more advanced data visualization, where we can show, like in this case, Newman's exact journey to Rome and all the things that he was writing in his diary and the documents he wrote along the way. Clicking on one of them opens that journey to Rome. You know what he was doing in Rome at that time. And if I open one of those documents, I see that journey also in the document if I want to jump to a different one. The sunburst is merely a way to tap into the main concepts of Newman, in this case, conscience. And then what was Newman saying about? What was he saying in 1881? And then this opens up loss and gain, and it does a search on conscience. It's just a way for users to dive into it more quickly. Just today, one of my colleagues, Elizabeth Huddleston, noted that Newman went to Switzerland and some other places. So we're thinking about adding those to our operations. Another thing, have the ability to crop and rotate inside of these documents, as well as do layers. So here I am rotating the image in the admin interface. And let me just skip ahead since we're running out of time here. Now we're in the main interface. I actually cropped it. You can see that the cropping is gone, and we can give the user the ability to rotate, to do their deep zoom, to change the lightness or contrast, to change the hue or saturation, or even to make it automatically make it black, invert it. I think the next one is an inversion, and then to zoom in. So these are research tools that allow you to do that imagining at a deeper level. And finally, the layers. This is fascinating because we can actually put multiple layers in the same canvas. So in this one area, we can place multiple layers on top of each other. This is the Dream of Gerontius by Elgar, his original score. And what I've layered is backlighting version of this document. And if I zoom in, we can see where Elgar made changes to the manuscript. And so we can study it in unique ways that you can't do with the physical manuscript. Again, the idea is to unlock the imagination. Now, future possibilities, we could acquire new collections, which we have already. 12 or 15 people have contacted us because they want to do more, because they've discovered, they've imagined, and they want their collections to be part of our collections. We're looking at possibilities of using a German transcribus software, which will allow us to do optical character recognition on handwritten documents. We'd like to crowdsource transcriptions where we let our users transcribe for us and keep versioning, user tagging so that when they find something that's meaningful, they can tag it and share it. We'd like to expand our data visualization in ways that maybe we didn't consider, ways that our users would be interested in, and maybe even offer our platform as an open source model or software as a service. Because it's so modular, the brilliance of this platform can be used with others, and we've considered even sharing it with like institutions who share our mission, because the effort that we've gone over the last few years could bear fruit with their collections as well and make our collection stronger at the same time. So I think I'm out of time. I really thank you for your for being with me. As you can see, I get a little jazzed up about this stuff, and for good reason. I think it's the future of history. It's the future of many things. So thanks for being with me. I'll open it up to questions. It might be, let me stop the share, and I'll go to the chat. If you could maybe post your questions to the chat area, and then I'll call on you, and just put your name and I'll call on you. Okay, Rob Bahari, are you able to unmute yourself, Rob, or do I have to do it?
Yeah, it looks like I can.
Okay,
Hey,
great.
Danny, so when you were talking about the archivist who's able to recognize whenever Newman was angry or not, like, have you given any thought to kind of opening up those text pieces and doing anything with artificial intelligence where it would kind of machine learning look up those kind of patterns for you, and similar with the OCR that you have with making that open to corpus analysis?
Absolutely. In fact, there are people doing just that with the Transcribus platform. The accuracy is astounding with that platform, but it's in our roadmap for artificial intelligence. It's sort of, for me, it's sort of like the feeling I had when I first encountered IIIF, and I had that deer in the headlights feeling. Now that I'm working closer to it, I'm feeling more comfortable, like this is definitely something that's going to happen in the future, particularly now that we have such a handle on our data and our recipes, as I call them in this presentation. So excellent observation, Rob. Yes, I think that's the future for us, for doing some kind of AI, not only with Newman, but with a lot of other people that he corresponded with that are new for us. Excellent point.
Thanks, Danny.
Stacy, are you trying to you can just unmute yourself.
Figured I would do a hand raise. It felt very fancy.
The only problem is they're not all on the screen. That's why I gave them the option to the chat for the chat.
Oh, God, no, either works. Well, thank you for the presentation. Sorry, I was back-ended on another meeting, so I came in a little bit late, but just curious, who's what the expertise composing your team now for doing this? So what kind of backgrounds that they need to be able to make this machine keep moving forward?
That's an excellent question. Our primary development stack is what's called the mean stack, which is MongoDB, Express, Angular, and Node. That stack is what we develop the primary things with. We have experts in React. Then the main interface is all Angular, as I mentioned, but it all takes place in the cloud. So it's mostly web technologies. Does that answer your question?
I think so. I mean, it's still, a bit of a mystery to me what the expertise is that you need for React or Angular. But, you know, I think more foundational of like, this is somebody who would come from the media department, like people who can use the
Right.
software, who are well-versed in specific software. Is that the,
Yeah, anybody that can do front end type software development, like JavaScript, if they know JavaScript, they can learn almost any of these other languages. So it's front end language heavy. Then the other side of the coin is if there are people who are cloud architects, probably 50% of the puzzle is the DevOps. The other side is all front end developers, very JavaScript heavy. If you know JavaScript, you know the other languages. So that should probably answer your question.
yeah, thank you.
You're welcome.
Danny, maybe a very practical question that might be of interest to faculty and some students here. What types of skills can be cultivated or improved through internships or work study opportunities at NIMS?
You mean as far as what you want the students to have coming in, or what we provide in return?
I think I think what NINS can offer.
Well, I think like right now, one of our current students who I actually see on the screen right now, John Winger, I don't mean to call you out, but what we do is every week as part of our training, like right now, John is working on doing some of the things that we discussed in the presentation, the cropping and the editing of the manuscripts. And each week we go over one aspect of the system, how we developed it and how he interacts with it, so that by the end of the internship, he can walk away with a pretty good understanding of how digital humanities works in an archiving environment. And it was similar in the past when we've had people doing the front end part of the optical character recognition, entering into the system, and now they're modifying the data. They sort of walk through the flow, and then we train them on how we're actually doing that on the back end. Does that answer your question?
Absolutely. Yes. Thank you very much. I think we're near the top of the hour. Maybe one last question from anyone?
I'll throw out a question, Danny. I'm just curious, if we think about the next year and then maybe say 5 years out, what are you most excited about as far as what's coming next?
I think as far as what's coming next is sort of some of the things that Rob mentioned, that taking it to the next level as far as doing further analysis on our documents. But to be honest, I glossed over it quickly. Ken is going to smile when I say this because he's been involved in a lot of these contracts. You know, you might not know this, but Ken is an international man of mystery. He seems to know everyone around the world. And we've acquired all of these additional collections. Our archivist is also on the front lines of Twitter and Facebook whenever we have something new. And our new newmanreview.org, we publish findings of what we've done. And what we found is people are continually contacting us and saying, we found these letters, we have these letters, would you like them? Next thing you know, you have another 10,000 letters and another 10,000, another 10,000. Our archivist currently has enough metadata to go until he is about 5 years dead, you know. So within the next 5 years, I expect exponential growth in our collections, number one, then making associations we didn't expect, and possibly even figuring out how can we make this more integrated either at Duquesne or with other institutions, with other libraries. You know, what can we do with what we're learning? Because we really had to knock a lot of heads to get this done. So I'd like to see this blossom into something new, either with Duquesne or with our sister institutions in the Newman world or beyond.
Okay. I think we're at the top of the hour, and that's a great way to close. Thank you very much, Danny. That was a very enlightening and enjoyable presentation, and I'm eager to see other ways that NINS and Duquesne NINS and Catholic Studies and other departments at Duquesne can find ways to collaborate with the work that you're doing in digital humanities.
I look forward to it. Thank you.
Thank you, everyone, for attending, and we look forward to seeing you in other contexts. God bless.